You watching? Hopefully you'll be, I have it positioned kind of to the side, but hopefully you'll be able to see still. Can you see okay?
Yeah.
My eyes might be messing with me, but I feel like the pickle's struggling.
Maybe it's
You see the pickle move too?
I think so, but I have terrible eyes.
Well, they didn't turn anything on.
Yeah, he's been slowly applying it.
What's it explode?
Can you blow it up?
It's not going to explode, is it?
It should glow.
Kids use like back away.
I don't know what it's like pickles all day.
I can't tell
Are
if
you
it's
turning
me,
up the
but I feel
energy
like
right
it's
now?
expanding.
Yes.
Yeah.
Yeah. It's getting bigger. 2 plus 2 equals 4 minus 2. 2.
I don't know.
It looks like it. It looks like it's getting bigger, actually. See, that's what I said.
You might want to back up.
Like seriously, kids use
Like back up.
I wonder if it's too bright in here to see anything too.
Close the door.
Close the door.
Yeah, the blind. I kissed the blind over here.
What the heck?
Blind side.
He's not using that.
Well, you see.
Close it all the way, Kizzy. Kizzy, no, all the way. Because it'll open on its own.
Doesn't do anything.
Now I can't see that.
I'm going to switch and go from the variable just to full and see if that does anything too. Like I said, trial and error.
Ready?
That's one way to die. You hit the head with a pickle.
Oh, we got smoke.
Oh!
Looks like a firefly.
Fry it. Oh, that's a fried pickle.
Can you see it?
Yeah.
Go ahead.
I want to try that.
Air out the window before the fire department comes. I tell them why.
Fried pickle.
So let's talk about.
Ooh,
we
it smells
did
like
have
pickles.
a glow finally, right?
It's gonna explode.
And if we get a stench, I'm sorry about that.
I like
So,
pickle smells.
Let's talk about why we had that happen. What do you think happened? What does electricity do? How does electricity travel? Yes.
It smells like pickles.
Well, particles, right? We were talking about water. What else? Electricity, electrons. Yes. Electricity's energy. When you apply electric current to the wires, it actually speeds up the particles along there. And ooh, that's starting to smell good, isn't it?
Love smell pickles.
Yeah, no.
Dude, I would totally wear a pickle perfume.
I would buy that.
I want it.
That hot? Probably was hot a few minutes ago.
Maybe one day.
I'm going to unplug just in case. When you apply electric current to wire, it speeds up all the electrons in the particles, right? It excites them. It makes those particles vibrate. You get the energy traveling like that. So with electricity current being applied to that pickle, you have all the particles in there getting excited. What is a byproduct of all that excitement? Temperature change, right? Because the particles are all traveling together, colliding into each other. That's why your cords are actually wrapped, right? Because if you ever grab onto your Christmas tree cord, like in Christmas Story, with everything plugged into it, the cords get hot, right? What else is in a pickle? We talked about that. Do you remember what we said was mainly in a pickle? You said water. True. What else? What do they put in the water? Vinegar. What else? Salt, which is, believe it or not, salt is a soft metal. It's on the left side of your periodic chart. It said alkaline. If it's a soft metal and an alkali, it does conduct electricity very well. So when all the conditions were right to do that. The things that I read in my little short history on YouTube and in the articles was the pickle is also a bit of a resistor. In electricity, a resistor slows down the current. So that may have been why when I was trying to electrocute the pickle, it took a little bit of time for it to actually get all the energy through there. What happens in real old electronics, what they would do for resistors was they would take a wire and they would coil it up like a ballpoint pen spring if you've ever tore apart a pen. And they'd wrap it around stuff because the longer that the electricity has to travel through a wire to get to something, that the slower the energy is for it. And then what they have to happen is they have to step up and step down energy. If you've ever seen the live wire demonstration that they do, electricity actually travels, they have to amp it up, they have to get the power up to travel along the lines that you see alongside the roads. And then the barrels that you see that are hanging on the power poles, they have to step the electricity back down so it's safe enough to go into your house. What else that but it's mainly physical observations. What did you see? Physical observation would have been, you saw smoke, and that kind of scared me.
It was lit up inside.
You also saw it flickering, right? One of the things that happens with energy too, you know, if you see light, that is a form of energy. That was the whole thing that Edison had going. If you have something that has enough energy traveling through it that you get light, that's good. Edison had to play with this a lot when he was making the light bulb because he was doing something similar to this. He was trying to energize a wire to get it to glow. The wire was too thick for him to get the electricity to go through it, so what he started experimenting with was smaller and smaller wires, and finally what he arrived at was a piece of thread that had carbon on it, and when he attached that to it, the thread would actually stay aglow for a while, and it was thin enough to carry that current through it. But that you know, if we get into chemical reaction, if you are applying a current through it, and I'm not getting into the actual technical stuff, but there's other chemicals at root in these pickles too, and when they get into the deep science of it, there are some other chemical reactions going there. But it's just like the energy thing, you know. When we did the experiment yesterday, and you put the salt in that thing, it was a catalyst that got things going. So that's the electric Pickle Lab. I thought it was pretty cool. Went just as good. On the YouTube ones, what they do is they put a piece of graphite pencil in one end and a galvanized nail in the other one, or they put a piece of tin foil on one end and graphite on the others, because if you can get the different types of metals to react against each other, you can get different reactions. And that's kind of like what happened here with the alkaline sodium and some of the other elements that are in there. You get these different reactions going there. So there's lots of variables. One variable I saw where they had different things hooked up to it, and I kind of did this cheap and easy. They actually had it flickering back and forth, which was cool. It looked like a little strobe light. We can try it one more time, and then, because we didn't light the school totally on fire, we'll try one more time. We'll see if there's any content left in here then. Ready? Here we...
Do we have to do this one too then?
No, let's just watch this one. Okay. It is...
Is the other side gonna light up?
I don't know what's going to happen. Did I... Oh, I took out the wires. Hold on. Let me unhook so I don't electrocute myself. That'd be rather unfortunate. Might be funny to you all. Ooh, I got pickle juice. Alright, one more time. Am I all plugged in? Almost. Ready? Ramping up here.
If you go outside and do this and let it burn.
Oh, ooh, you know what I got?
That's so scary.
Dude, imagine you steal someone at Halloween, you green pickle. Like, oh, it's someone to pickle.
Would you like a light?
Can I eat that?
It's a little bit hot.
Okay. Ooh, oh, man.
They're playing with the pickle. Christian.